Welcome to today's deep dive. Our mission today is to extract a really profound micro lesson in observation, problem solving, and, well, how living things physically adapt to their environments.
Yeah, and it's a very unique angle we're taking today.
Right, because we are doing this by looking at a highly specific, kind of fleeting snapshot in a single gardener's journey. So we have an excerpt today from an extensive online gardening journal.
Extensive is definitely the right word for it.
Yeah, it really is. It is titled Notes on Gardening Part 971, Managing Sunlight for Honey Melon, Cucumis-melo. It's authored by someone named Ang, and it was actually published today, July 30, 2026.
It's just a fantastic piece of source material to dig into. It really is.
Okay, let's unpack this, Part 971. I mean, that number alone tells us we aren't looking at a casual weekend hobbyist, just writing down a few stray thoughts about a houseplant.
No, absolutely not.
Documenting a garden nearly 1,000 times requires a staggering level of dedication. It means we are basically dropping right into the middle of a very delicate, ongoing biological drama. Ang is intimately familiar with these cast members.
It shifts our perspective entirely, doesn't it? I mean, usually when we think about survival in nature, we picture grand, sweeping landscapes,
Yeah.
the macro scale.
Right, like lions on the savannah or something.
Exactly. We picture a massive redwood forest, a sprawling jungle, or, a sheer cliff face. We expect the drama of survival to look like something out of a high-definition nature documentary.
Where the stakes are just really loud and visible.
Yes, precisely. But this is different. It's much more subtle.
Right, but when you zoom all the way down, like past the canopy, past the garden gate, right down to a single windowsill and a tiny plastic tray of dirt, you realize the fight for survival is happening in real time, right there.
It is. The stakes are exactly as high for that individual organism. The battlefield is just measured in millimeters, not miles.
Yeah, and in many ways, that microscopic battlefield requires a much sharper kind of observation to truly appreciate, doesn't it?
Oh, absolutely. While Ang's journal entry is quite brief, I mean, it's just a few paragraphs and some photos, it perfectly encapsulates the daily, invisible mechanisms that drive life.
It kind of forces you to slow down.
It does. It forces us to slow down and read the subtle language of living things.
So let's meet the protagonist of today's deep dive. We are dealing with honey melon seedlings. Ang notes that these sprouted seeds were recently transplanted.
Right, a very stressful event for a plant on its own.
Exactly. But they've grown taller, and they've reached a very critical milestone. Some are showing their first pair of what Ang calls cotyledon, or seed leaves.
Ah, yes, the cotyledon stage. It is a pivotal moment in the life cycle of any plant.
That's the big deal, though.
A very big deal. To understand the dilemma Ang is about to face later in the journal, we absolutely have to understand the biology of what these honey melons are experiencing in this exact phase of life.
Because they aren't just tiny adult plants, are they? Like, when I saw the term seed leaves, I immediately started thinking about how they function.
And how did you picture them?
Well, are cotyledons essentially a plant's starter pack?
Yeah.
Or like the biological equivalent of training wheels for life?
A starter pack is a highly accurate way to visualize it, actually. Before a seed ever touches the soil, it is essentially a sealed biological vault.
Okay, a vault. I like that.
Inside that hard outer shell, there is a tiny, dormant embryo. But crucially, attached to that embryo is an endosperm. You can think of the endosperm as a packed lunch.
A packed lunch inside the vault.
Exactly. It is a highly condensed, finite store of starches, proteins, and oils.
So it comes prepackaged with everything it needs.
Uh-huh.
Like it's completely self-sufficient at first.
Yes. When you plant a seed, it doesn't need anything from the outside world except a little moisture and warmth to break the seal on the vault.
Just add water.
Right. The water rushes in a process called imbibition, and the embryo wakes up. At that point, it grows entirely in the pitch black of the soil, living exclusively off its savings account.
But wait, if it's completely in the dark and it doesn't have any leaves yet, how does it even know which way to grow?
That's a great question.
Like if I'm a seed buried underground, I don't know up from down. How does the plant know?
That relies on a remarkable mechanism called gravitropism. The plant has specialized cells containing tiny, dense starch grains called statolyths.
Statolyths. Okay.
Yes. Because these grains are heavy, gravity pulls them to the bottom of the cells. The plant senses where those grains settle and uses that information to basically navigate.
Oh, wow.
It sends the root downwards toward the pull of gravity and the stem upwards against it.
That is wild. It's
Hmm.
essentially using internal heavyweights to navigate blind. So it's completely independent at that point, just relying on gravity and its packed lunch.
Yes. But what's fascinating here is how rapidly that independence vanishes. The appearance of the cotyledons, those seed leaves Eng documented, marks the exact moment the biological savings account runs out.
Oh, so the training wheels come off.
Exactly. The plant has breached the surface of the soil. It has unfurled these specific seed leaves, which, usually look completely different from the true leaves that will grow later.
Right.
And it is actively trying to act like a solar panel.
Ah, I see. So it's transitioning from being this self-contained unit to being entirely dependent on its environment.
Precisely. Noting the cotyledon stage is really about observing vulnerability. It's a moment of profound transition for the organism.
It's basically waking up and screaming for food.
Pretty much.
Yeah.
The plant is essentially saying, I am here, my packed lunch is gone, I am hungry, and if the environment doesn't provide for me right now, I have absolutely no backup plan.
Which leads right into the central conflict of Aang's journal entry. So the seedlings have their training wheels on, they're demanding energy from the world, and there is a problem.
A major problem.
Yeah. Aang observes that the specific microclimate where these seedlings were placed lacks the full sunlight exposure required by honey melons.
A critical environmental failure right at the moment of peak vulnerability.
Exactly. And here's where it gets really interesting, because Aang notes a direct physical result of this lack of light.
Yes, the photos in the journal show it clearly.
The stems of the seedlings are leaning, like they are physically tilting over. But before we get to the biology of the leaning, I want to push back on Aang's terminology for a second.
Oh, what part of the terminology?
Well, why use a fancy word like microclimate? I mean, isn't sunlight just sunlight?
It's a common way to think about it, sure.
Right. Like if you put a plant in a room with a window, it's getting light. It feels like we might be sort of overcomplicating a windowsill by treating it like its own distinct weather system.
Well, it is a very common human misconception, mostly because of how our eyes work. Human eyes are incredibly adaptable.
How so?
Our pupils dilate and adjust automatically, so when we walk into a room with a window, our brain basically processes the entire room as being uniformly lit.
Yeah, exactly. To me, the lights are either on or they're off.
Right. But to a vulnerable seedling relying on photosynthesis, a room isn't just lit or unlit. Light is radiation.
Okay, radiation.
And the concentration of those photons drops off exponentially the further you get from the source. It's just basic physics, the inverse square law.
Okay, I think I see where you're going with this.
A seedling sitting just 2 feet away from a window pane might be receiving, say, 75% less usable light energy than a seedling sitting right up against the glass.
Wow, 75%. Okay, wait, I think I get it. Tell me if this tracks. It's kind of like finding that one specific spot on your couch where the Wi-Fi actually works.
That is a perfect analogy, actually. Yes.
Like, the whole living room is technically supposed to have internet. That's the macro environment. But because of the dense walls, or maybe the refrigerator in the next room is blocking the signal, there's this one invisible hyperlocal zone on the left cushion with its own completely different rules.
Where the signal just drops entirely.
Yeah. That's a Wi-Fi microclimate.
Yes. The router is the sun. And just like your Wi-Fi signal, the sun's radiation gets degraded, blocked, and bounced around by everything in the room.
So a room is actually full of different light zones.
Exactly.
Oh.
The shadow cast by a single window frame, the subtle reflection off a white wall, the angle of the glass. These all create hyperlocal zones of light and temperature. The environment is full of sharp gradients that human eyes simply filter out.
And Aang's keen observation caught that this specific seedling tray was unfortunately placed in a deficient one. The Wi-Fi signal of the sun was dropping out right where the honey melons were sitting.
Right. And we know this because the plant is actively communicating its deficit.
By leaning.
Yes. You mentioned the leaning stems. That is a real-time, physical manifestation of a flawed microclimate.
It's basically the plant buffering. It's struggling to connect, so it's physically reaching out to find a better signal.
It is struggling, yes, but it isn't actually reaching in the way a human would, reach out an arm.
Well, obviously it doesn't have arms.
Yeah.
But it is moving, right?
Yes. Plants possess a mechanism called phototropism. Because they cannot get up and walk to a better spot, they grow toward the light source. But the cellular mechanics of how they do this are pretty remarkable.
Okay, so how does a plant physically bend itself without any muscles?
It relies on plant hormones, called auxins. When a light source hits a plant from one specific direction, the auxins actually migrate away from the light.
They move away.
Yes, they gather on the shaded side of the stem.
Wait, they move to the dark side of the plant. Why wouldn't they go toward the light?
Because auxins cause cell walls to loosen and stretch.
Oh, I see.
So as the auxins concentrate on the shaded side of the stem, the cells on that dark side begin to rapidly elongate and fill with water. The cells on the sunny side, however, just stay their normal size.
So one side is getting taller than the other.
Exactly. So as the dark side gets longer and longer, it physically pushes and bows the tip of the plant over toward the light.
That is incredible. It's uneven growth disguised as a reaching motion.
It is, but it comes at a massive energetic cost. This rapid stretching a stress response, called etiolation, means the plant is prioritizing length over strength.
It's panicking.
Truly, it is desperately throwing all its remaining energy into getting taller to find the signal. And that results in a stem that is elongated, pale, and incredibly weak, rather than thick and sturdy.
Okay, so to summarize the biological drama so far, our honey melon protagonists have breached the soil, they've opened their seed leaves, spent every last drop of their internal energy, only to find themselves in a dead
A
zone.
very harsh reality.
It triggers this panic response, where hormones flood the dark side of their stems, forcing them to frantically stretch and lean just to survive. I mean, it's an incredibly tense situation for something just sitting quietly in a tray.
It really is a true fight for survival. And it brings us to the crux of Eng's journal entry, the gardener's dilemma.
Right. What do you do?
How do you intervene when you see this happening?
Well, having identified the problem, the leaning stems and the root cause, a light-deficient microclimate, Eng proposes two distinct solutions in the journal.
Yes, two very different approaches.
Approach 1. Turn the seedling tray to face the opposite direction. This would place the sunny side in the shade and essentially force the leaning stems to correct themselves by growing back the other way.
Making them work for it.
Right. Or approach 2. Simply move the entire seedling tray to a completely new microclimate that naturally offers the full sunlight exposure the plants actually need.
Two profoundly different philosophies of problem solving right there.
So what does this all mean for the plants? Honestly, looking at the biology we just discussed, I have to ask, is that first approach just fundamentally flawed?
Well, why do you view it as flawed?
I mean, just turning the tray around so they lean the other way, isn't that just a massive Band-Aid fix?
A Band-Aid.
Yeah, it feels like stretching a sore back without buying a better mattress. Or, rotating your car tires instead of actually fixing the broken alignment that's wearing them out in the first place. You aren't fixing the lack of light, you're just manipulating the plant to work twice as hard to stay centered.
You call it a Band-Aid, but we have to remember that in the natural world, biological adaptation is essentially a series of Band-Aids.
Is it?
Yes, plants in the wild do not have the luxury of uprooting and moving to a better mattress. They are literally rooted in place.
Okay, that's true.
They have to play the hand they are dealt, constantly adjusting their internal chemistry to survive flawed environments.
Okay, fair point. In the wild, they are stuck. But this is a Darden. Aang can pick up the tray and move it. I mean, Aang is the one dealing the hand here.
True, but gardening, much like life, involves hidden constraints.
What kind of constraints?
Well, why didn't Aang just put them in the perfect spot to begin with? Perhaps the microclimate with full sunlight is too hot for those fragile new leaves.
Oh, right. They could burn.
Exactly. Or perhaps it is exposed to harsh winds. Or, quite possibly, there simply isn't enough physical space left in the ideal spot because, as we know, there are at least 970 other projects happening in this gardener's life.
Ah, the reality of limited resources. That makes sense.
Yes. If we connect this to the bigger picture, Aang is weighing two distinct methods of intervention.
Okay, lay them out for me.
Approach 1, turning the tray, is about managing the symptom. You leave the organism in a deficient environment, but you artificially balance the stress.
The plant leans left, so you spin the tray.
Right. The auxins migrate to the other side, and the plant spends more energy stretching to the right. It requires constant human intervention and constant energy expenditure from the plant.
Because the plant is trapped in a cycle of constantly correcting its posture.
Precisely. Now, approach 2, moving the tray, is about curing the disease entirely.
You change the environment.
Exactly. You entirely change the environment to suit the inherent genetic needs of the organism. You provide the full sunlight the honey melon requires, stopping the panicked etiolation entirely.
So you basically fix the Wi-Fi router. You just put the plant where it's supposed to be.
In a perfect world, yes.
It seems so obvious when you lay it out like that, but I guess when you factor in constraints, you don't always have the luxury of perfectly changing your environment. Sometimes you just have to turn the tray to keep things from falling over completely.
And I think the real beauty of this journal entry is how Aang concludes it.
Oh yeah, the sign-off.
Aang doesn't declare one method morally or scientifically superior right then and there. After proposing both the symptom management and the environmental cure, Aang simply signs off with, "Let's see how this goes in the coming days."
The ultimate scientist's perspective. It's not a rigid mandate. It's an ongoing experiment.
It's the patience of someone who truly understands that living systems take time to process change. You observe a deficit, you implement an intervention, you wait for the biological response, and then you adjust again.
That is just, I mean, it's a huge lesson packed into such a tiny observation. And as we wrap up this deep dive, I think it's really important that we bring this home to you, the listener.
Absolutely. Because while Aang is carefully monitoring the auxins and phototropism of melons, the principles of adaptation are universal.
We are all interacting with our environments, constantly making demands and responding to deficits.
We really are.
So, take a moment today and consider your own microclimates. Think about the physical and mental spaces where you spend your time, where you sit to read, where you do your work, where you try to learn new things.
Are those environments actually providing the full sunlight you need to thrive?
Right, or are you finding yourself in a dead zone?
Are you in a space that naturally supports you with the right resources and the right energy?
Or are you constantly leaning? Are you finding yourself straining, adapting, and basically twisting yourself into knots just to get by in a deficient environment?
It's a vital diagnostic question for all of us. Are you burning all your internal energy trying to fix a leaning stem by just turning the tray back and forth, when what you really need is to pick up your tray and move to a better window?
It really makes you evaluate the band-aids in your own life, like
Sure.
whether you are just treating the symptom or actually changing the environment.
And this raises an important question, a final biological thought I'd actually like to leave you with today. It builds on Aang's first solution, the physical act of turning the tray.
Oh, okay, let's hear it.
Well, in botany, there is a phenomenon where physical stress, like wind or mechanical touching, actually causes a plant to grow shorter and thicker to protect itself.
Like calluses?
Basically, yes. So if a gardener constantly turns a tray back and forth to correct a leaning stem, the plant is forced to continuously stretch, reverse its hormones, and fight against its environment.
Okay, yeah.
Does that constant struggle, that repeated mechanical correction, actually build a thicker, more resilient stem over time, almost like a muscle lifting weights?
Oh, wow. I didn't think about that.
Or, and this is the flip side, does that endless oscillation in a light-deficient room permanently exhaust the plant, depleting its vital energy compared to a seedling that was just given perfect, steady sunlight from day one?
Wow. Does the constant struggle to adapt make us stronger? Or does it just permanently wear us out?
It's something to think about.
That is an incredible thought to end on.
Yeah.
Well, a massive thank you to Aang for documenting the journey of those tiny honey melons and letting us peer into part 971 of the process.
That was a pleasure to analyze.
And a huge thank you to you, our listener, for joining us on this microscopic but mighty deep dive. Keep examining your microclimates, and we'll catch you on the next one.